Question 6. Part A. A wooden block of weight 5 newtons is pulled along a horizontal table for a distance of 50 centimetres by a force of 3 newtons. How much work is done? Right, well, if we draw the picture of it, wooden block of weight 5 newtons, it's pulled along a horizontal table, so that is the direction that it's moving, that's the distance, horizontal, for a distance of 50 centimetres by a force of 3 newtons. Right, they've tried to confuse you here because they've given you two forces. How much work is done? Well, work equals force times by distance. But do we use this force, which is going downwards, or do we use this force, which is going across? Well, the distance is going across. The distance is horizontal. So we need to use a horizontal force. So we can forget about that one. And also, we do need to convert the centimetres into metres. So that's another way that they've tried to trick you. So 50 centimetres is 0.5 metres. So we'll do 3 newtons times by 0.5 metres. And that comes out as 1.5 newton metres, or 1.5 joules. They do prefer to put the units of work in the same units as energy, which is joules. So there's your 1.5. Your answer is D. If you didn't convert, you would have thought that the answer was B. Or you may have even used the 5 newtons and the half, which you'd have thought was 2.5, that was wrong. Or 5 and the 50, which is 250, and that's wrong. So very tricky. Part B. An electric motor is used to lift a weight of 26 newtons. So that's the weight. A gravitational potential energy of the weight changes by 180 joules. So that's our gravitational potential energy. Calculate the distance, so D, is a question mark, by which the weight rises. Now, distance could be called a height, because when we're dealing with gravitational potential energy, we're thinking about how high an object is off the floor. The higher you go, if that's object A, object B is higher. So object B, if it was the same mass as object A, object B would have more gravitational potential energy. Because to calculate gravitational potential energy, you do mass times by gravity times by height. Now once again, they've been a bit tricky. They haven't gave you a mass, they've gave you a weight. Now, weight equals mass times by gravity. So we can take this mass times by gravity and we can replace it with the weight, because they've gave us the weight as 26. So we can just put mass times by gravity, that's 26 newtons. And that would be times by the height, and that would be giving us our gravitational potential energy, which is 180 joules. So we need to rearrange that then. So the height is just going to be 180 joules divided by 26 newtons, which is 6.92 meters. Right, part 2. The input power of the electric motor is 60 watts. So that's power, which is of course energy per second. The system is 50% efficient when lifting the weight. Calculate the time it takes for the motor to lift the weight. Right, to calculate the percentage efficiency, we need to know the energy that's coming out useful divided by the energy that we put in total, multiplied by 100 to turn it into the percentage efficiency. So if we rearrange that, so therefore, to get the total amount of energy, we need to know the useful energy multiplied by the 100, and we'll divide that by the percentage efficiency. Now, to do that as a magic triangle, see this as just one thing, and then literally what you've got is just three things. So there's a magic triangle. If I call that 1, 2 and 3, then basically I've got 2 divided by 3. So 2 goes on the top shelf out here, which means it goes on the top shelf in there. And it doesn't really matter whether I put 1 and 3 as 1 and 3, or if I put 3 and 1, because 1 times by 3 is the same as 3 times by 1. 4 times by 2 would be the same as 2 times by 4. So it doesn't really matter which way around you put the 1 and the 3. So that's all I've done there. You'll notice, in order to get the energy total, which I called number 3, it would be 2 over 1. So it would be 2 over 1. Okay? Again, if you're confused with that, have a look at my magic triangle video. Right, so the useful energy was 180 joules, because that's the energy that the object's got stored inside it because it's been lifted up. I could drop that object and I could release that energy. I could use that energy as the object's fallen in order to lift something by using a pulley system. So that energy is useful. I'll multiply that by 100 and I'll divide it by the percentage efficiency, which was 50. And that comes out as 360 joules. But all I've done there is worked out what the total energy was. Now, we need to work out the power. So there's another equation. Power equals energy transferred over time. Right, we're trying to work out the time, calculate the time. So we need to rearrange this equation. So once again, I'll do a quick magic triangle. So E is on the top shelf out here. So that means it goes on the top shelf in there. And I've got P and T. So I've got 2 things and 2 spaces. Just shove those things in those spaces. It doesn't matter if it's P times by T or T times by P. It's like I said before, 4 times by 2 is 8. And 2 times by 4 is also 8. So it doesn't matter if it's P times by T or T times by P. Now cover up what you're looking for. We're looking for T. So cover up T. It is E divided by P. So T equals E divided by P. The energy that we've worked out was 360 joules. That's the total energy. And we need to divide that. The power of the motor was 60 watts, which means that every second it's transferring 60 joules of energy. So divide the total amount of energy that we've transferred and divide it by the power, and that'll come out as our time, which is 6 seconds. Now that was a lot of work for 3 marks, but this is a higher paper and they do make you work harder. And finally, the last question. A student wants to determine the useful power developed when a person does a physical activity. Explain the measurements that should be taken during a suitable physical activity and how the measurements should be used to determine the useful power developed by the person doing the physical activity. Now, what I do with my students is I do a physical activity where we run up the stairs. Now, in order to know the power of something, we need to know how much energy is being transferred and how long did it take for that energy to get transferred. If someone is capable of transferring more energy in a shorter amount of time, that makes them more powerful. Okay? So what we need to do, the energy transferred, remember, is force times by distance. Okay? So to get the force, all right, we're going to measure the weight in newtons of the person. Okay, what we're going to use, so measure the weight with scales. So tell the examiner what you're going to measure and then tell them what you're going to use to measure it. Now, as I say to my students, base your explanation on the calculation. So everything that I'm about to tell you now is based on this calculation. Now, I need to get the distance. So measure the distance moved by the person. Now, because weight is vertical, weight acts downwards, which is vertical, we need to know a vertical distance. Now, what are we going to use to measure the distance with? We're going to use a ruler. I'm expecting a mark because I'm telling them what I'm measuring and I'm telling them what I'm measuring it with. So I'm expecting 1 mark for that, 1 mark for that. I'm expecting 1 mark for telling them to measure the distance. I'm expecting 1 mark for saying I'm going to measure it with a ruler. I'm expecting 1 mark for putting the equation. I might even get 2 marks because I've got power equals energy over transferred and I've also got work done equals force times by distance. So I've already got a possibility of having 5 marks. But just to make sure, I'm going to tell them I need to measure the time with a stopwatch. Measure time with a stopwatch. Now, if you wanted to, you could actually underline them in the exam. Now, just to be sure, I'm going to repeat the whole thing and take an average. Now, if you just want them going up 1 step rather than a flight of stairs, you would repeat. Measure how many times they go up and down the stairs. If a stair was 20 centimetres and they went up 10 times, then that would be 10 times by 20 centimetres. So that would be the total distance. And that's how to take care of that. I hope it's been useful. Like the video if you'd be so kind. Subscribe to my channel and hit the bell so that you're notified every time that a new video comes out. Want to see more videos like this? Subscribe to my channel, GCSE Physics Explained. Thanks very much and bye for now.